In problem number 4, we will be finding the domain of f circle G, or the composite function of f and g, where f of x is equal to the square root of x plus 2, and g of x is equal to the square root of 3 minus x. And let's recall that the domain of the f circle G is the intersection between the domain of G and the domain of the prime of circle f circle G, which is the domain of the composite function that we're just going to solve. So to solve for the domain, we need to solve for the f circle G first. So f circle G is just equal to the f of the function G, which is the square root of 3 minus x. So the square root of 3 minus x will be substituted to the variable x of f, which is equal to square root of 3 minus x plus 2. Okay, now this is our f circle G. So in this expression or equation, we know that this is a radical expression. So there is a possibility that the value of the function f circle G is equal to imaginary. The value here could be negative, right? So in this case, we're going to get the radicand, which is equal to the square root of 3 minus x plus 2. And this must be greater than or equal to 0, or else the value of the function f circle G becomes imaginary. So this becomes, let's simplify, the square root of 3 minus x is less than or equal to negative 2. Okay, so let's go to the next step. However, the radical expression doesn't have, or the principal square root of a certain number will not give us a negative value. Okay, the minimum value of this is 0. So which means this statement is not yet simplified, but we can simplify it into 3, the square root of 3 minus x is greater than or equal to 0. Again, we change 0 from negative 2 since the minimum value of square root of 3 minus x is 0, and it can never have negative values. So therefore, by simplifying, we have 3 minus x is greater than or equal to 0, and x is less than or equal to 3, right? So therefore, this is our domain. This is the domain of f circle G prime, okay? Which is equal to x is an element of real number such that x is less than or equal to 3. Now, let's now solve for the domain of the composite function f circle G considering the domain of G. So here, we're going to follow this formula. Okay, so we have the domain of f circle G is equal to, the domain of G is, let's use interval notation. We have x is less than 3, all right, x less than 3, and intersection with this, x is less than 3, right? So we have the same interval. Okay, so this becomes, the intersection is x is less than 3, of course, which is the domain of f circle G. So therefore, our final answer would be the domain of f circle G is equal to x is an element of real numbers such that x is less than or equal to 3. All right, so that's our final answer.